through 1 or 4. And lesson 101 is about factorable denominators. So I'm going to give you a very basic example of what we are going to do. So this is going to kind of look silly because what I'm going to do is I'm going to take 3/6 and I'm going to expand it out. So we could rewrite this as 2/3 plus 3 over 2 times 6, right? Rather, 2 times 3. Okay, so at this point, we could either cross cancel our 3 and our 3, or we could multiply our first fraction by 2 over 2. So that's what I'm going to do, multiply our first fraction by 2 over 2, and we get 4 over 6 plus 3 over 6 equals 7 over 6. Okay. So what we're going to do in this lesson is very similar to that, only with more complicated equations. So we have 6x over x squared minus x minus 12 minus p over x minus 4. Okay, so now what we have to figure out is how can we factor this denominator, because we have to have common denominator in order to subtract these. So the nice thing is that you can look at this, and this will probably have something in it. I'm sorry, the circled one, will most likely factor into x minus 4 times something else. So if we look at it, we can see that it can factor into x minus 4, x plus 3. And we can see that because we know it's addition and subtraction because of that negative sign before the 12. That negative sign says we're going to have two different signs. And the negative sign before the middle term says we want the larger of the two to be negative, and our 4 is negative. So now we're going to just rewrite the other half of the problem, p over x minus 4. And before we can add these two, what we have to have is a common denominator. So our common denominator is going to be x minus 4, x plus 3. So we have to multiply our second fraction by x plus 3 over x plus 3. Okay, it's really messy, but and we're going to leave it in factored form. So that equals 6x over x minus 4, x plus 3, minus p times x plus 3 over x minus 4, x plus 3. Okay, so now we just need to distribute this negative p to the x plus 3. That's always the tricky part. You want to make sure that you distribute that negative sign. So I'm going to scroll up my screen here and say that I'm going to combine them under one denominator now, because we can do that. 6x minus p x minus 3p over x minus 4, x plus 3. And if you wanted to, you could FOIL that, but there's absolutely no reason to do that. I'm going to go ahead and do the second example. If you can pause your video right now and try it on your own, that would be great, and then just check it with the video when you're done. So we have 7 over x squared minus 5x minus 6 minus 5 over x squared minus 6x. Okay, and we can factor the first one here. The minus sign before the 6 says I'm going to have an x plus something. Whoops. I'm going to have x plus something and x minus something. And then the minus sign before the 5, well, that means that we're going to have a minus 6 and plus 1. Don't know why my screen keeps doing that. All right, the other one is a pretty easy to factor problem. You just factor out an x and you're left with x minus 6. So our common denominator will be x plus 1, x minus 6. All right, now this tells us what we need to multiply each term by. We have to multiply the first term by x over x, and we have to multiply the second term by x plus 1 over x plus 1. So now let's combine 7x minus 5x minus 5. All right, but now I can add my 7x and my 5x and simplify that, and I get 2x minus 5 over x plus 1, x minus 6. Now, if I ended up somehow with an x minus 6 up top, we could have cross-canceled that. But since I don't have anything like that, or I don't have an x in both terms, I can't cancel anything out. But sometimes you can actually do some canceling out. All right, try those last 4 problems on your own, and we will go over them in our meeting. All right, lesson 102 is about absolute value inequalities. So let's just scroll down here for a minute and let me ask you this. If we had something like this, the absolute value of x equals 4. What does x equal? Well, if the absolute value of 4 is 4, that means the distance from 0 to 4 on the number line, okay, that's what it means. That's what we're talking about. We're saying if the absolute value of x equals 4, then we're talking about the distance from 0 to 4 on the number line. But what about 0 to negative 4? That distance is also 4 units, right? So what that tells us is that the absolute value of x, if the absolute value of x equals 4, then x could equal 4 or negative 4. And we would graph it like this. We'd say it equals 4 or it equals negative 4. But now we're going to be doing some inequalities. So let me erase this. And let's go back up top. And let's look at some of these. So if the absolute value of x is greater than 2, then we know it's not equal to 2, right? It's bigger than 2. So we would put an open circle at the 2. But we would also, what we know is that x is greater than 2, and that x is also less than negative 2, because when we multiply with because x could be positive, here let me redo that. so that it makes more mathematical sense, right? So x could be positive or x could be negative. But if x is negative, we have to multiply both sides of the inequality by -1, and that shows us that x is less than -2. So if x is greater than 2, then we have an open circle at 2, and if it's less than -2, we have an open circle at -2 going that direction. I know that these can be a little bit confusing, so let's go ahead and do the next one as well. X is greater than or equal to 3. Okay, so we can say x is greater than or equal to 3, or negative x is greater than or equal to 3. But we don't want to leave our x's negative, so we have to multiply by -1. So that means that x is less than or equal to -3. So in this case, we will draw a closed circle at 3 with a line going to the right, and a closed circle at -3 with a line going to the left. Now this next one, because these all seem simple until you get to problems like this, and this says that x is less than -4. And if we don't really think about it, then we can mess ourselves up a little bit. So the question is, are there any real numbers that satisfy this inequality? So what is a number less than -4? -3, right? But can we say the absolute value of -3 is less than -4? No, the absolute value of -3 is +3, which is greater than -4. So there are no real numbers that satisfy this condition, because the absolute value of any non-zero number is going to be greater than -4. So for this one, there is no solution. How about for the next one, though? Okay, it's a tricky one also, because every number is 0 or a number greater than 0. The absolute value of every number is 0 or greater than 0. So if we're saying the absolute value of x is greater than -4, then we can be sure that all real numbers satisfy this equation. All right, so if we were going to graph it, we would do so like this. And it would be all real numbers. So we would basically draw a line on top of the line. Go ahead and do the last of those practice problems by yourself, and we will go over those practice problems in For lesson 103, we have these complex equations that are similar to some equations that we did in lesson 78. We are going to be able to solve for a variable by eliminating the denominators. So what we want to do first, our first step is going to be to multiply each term by the greatest common, the least common multiple. So I remember when we did this before in lesson 78, a few of you had a hard time multiplying by the least common multiple. You were multiplying by, so for example, in our very first problem here, our least common multiple is 12. So you don't want to multiply by 12 over 12. You just want to multiply each term by 12. And that way, that's how we eliminate the denominator. So if I multiply here each term by 12, I'm going to stick it out in front because I don't have room behind. then you can see what happens. We can cross cancel, and here our 12 becomes a 6, so we get 6y, put my equal sign there, plus 3 equals 2y. So actually I did not need that equal sign. I don't know what I'm thinking here. I'm gonna get rid of that. Okay, so now that we have this equation, we can just solve for y. I'm just gonna bring my 6y over, minus 6y, minus 6y, and I find I'm gonna go to the right because I don't have room down below. 3 equals negative 4y. So y equals 3 over 4, but it's negative. Okay, let's do the next one because it has a variable in the denominator. So our least common multiple would be 3t because each element has a 3 or a t. So if we multiply each term by 3t, we can eliminate our denominator. So here, let's put that in parentheses and show we're multiplying by 3t. Of course, our t's cancel out, and we're just multiplying by 3. Multiply by 3t, and they actually cancel out on both. And multiply by 3t, and our 3's cancel. So if I multiply 3 by the first parentheses there, I get 3t minus 6 equals 14 minus t. And now we can solve for t. So if we add t to both sides and we add 6 to both sides, we end up with 4t equals 20 and t equals 5. So just looking back at this one that we just solved, 5, if we substitute it back in, we will make both sides of the equation equal. But what is something that t could not have been? Could t have been 0? T could not have equaled 0 because we have a t in the denominator, and division by 0 is undefined. Lesson 104 continues on with what we have learned in Lesson 103. So the first thing we want to do is eliminate our denominators, and that's going to make life a whole lot easier for us. In order to do that, we have to find our least common multiple, and here we have an x in the denominator and an m in the denominator. We are also told that m and x can't equal 0. So that makes sense because division by 0 is undefined. So it's just limiting what m and x can be. That's really all you need to know about that. So our least common multiple would be xm because we have an x and an m in each term. So I'm going to multiply each term by xm. I'm sorry, we don't have an x and m in each term. We have the 2 letters in the denominator are x and m. That's why we're multiplying each term by xm. All right, here our x's cancel out. Here our m's cancel out. Okay, and on our last term, none of them cancel out. So our first term is m plus xb equals cxm. All right, so we want all of our m's to be together. So let's bring cxm over here and move xb over there using subtraction for both of them. So we end up with, let's go ahead and show what we're doing here. I'm going to use another color. So we're going to show subtracting cxm from both sides and subtracting xb from both sides. So we end up with m minus cxm equals negative xb. Now, the answer keys for these are sometimes tricky. I'll be grading your tests from here on out, so I shouldn't, I won't have a problem, but sometimes if they solve it differently, your negative signs end up different. But if you were to multiply 3 with a negative sign, you would end up with the same answer. So I'm just warning you that sometimes your answer may not line up with the answer key, but it's okay. So here what we can do is pull out our m's, because we have m's in both terms, and that's what we're trying to solve for, is m. So if we pull our m out, go back to white, we're left with 1 minus cx equals negative xb. And now to get m by itself, we will divide both sides by what's attached to the m, 1 minus cx. Whoops, not ck, cx. Wow, something's weird. I don't know what I wrote. There's 1 minus cx. And so we are left with m equals negative xb over 1 minus cx. Why am I always trying to put a k there? Cx. And that's our final answer. All right, let's look at the next one. The next one we're solving for b, and it tells us b and d can't equal 0 because b and d are in the denominator. And so they can't be 0. So what are we gonna multiply each term by? Well, we want to multiply it by the least common multiple, which is BD. So if I multiply this by BD, this by BD, and this by BD, we end up with well, let's show what cancels out. So our B's cancel out there, and our D's cancel out there. This is probably a hard type of thing for someone with dyslexia, but all right, so we have, this is driving me berserk. Whoops, I'm gonna undo that. I'm gonna do it back in white again. So our first term becomes AD plus our second term is CB equals XBD. And what are we solving for? We're solving for B. So at this point we have B in 2 terms. So I'm just going to bring my B over here. And I get AD equals, show my subtraction here, I'm not sure why this isn't working right. Something to do with that line. Minus CB on both sides. Okay. I'm going to write this further down. So we show that AD equals XBD minus CB. All right, once again, I'm always reminding myself, I'm solving for B. So I've got to take my b out of here so that I have all my b's together. So b times xd minus c equals AD. All right, and in order to get b by itself, we have to divide both sides by what it's being multiplied by, xd minus c, xd minus c. So we are left with b equaling AD over xd minus c. Now, these often are tricky for people to do. Let's look and see if it would look any different if we had taken xbd over here instead of what we did, because this is why sometimes we end up with things looking differently. So let's redo that, and I'm going to just start. I'm going to do the whole thing in green, and I need to write down what I'm starting with. AD plus CB equals XBD. So if we had taken this over here and taken the AD over there, then we would have ended up with CB minus XBD equals negative AD. So if we had done that, then we would pull the b out over here, and we would have ended up with c minus xd equals negative AD. Then we divide both sides by c minus xd. And we would end up with b equals negative AD over c minus xd. So now let's take that and compare with what we did get. So is this answer any different than this answer? Well, our negatives are just in a different location. So you can see here my AD is negative and here it's positive. And my C here is positive, but my C here is negative. And my XD is negative, but here my XD is positive. So since all of the signs are just simply swapped, then it's the same answer, because we could just multiply this by -1 and we would get B equals -1 times AD is AD over negative C plus XD, which is the same thing as what we have there. So it's actually fine regardless of how you solve it, but it can be a little bit tricky when you're grading them. Okay, do the rest of the practice problems.